So today, as far as I'm concerned, is the most difficult factoring method possible. It's when we're asked to factor a quadratic of the form ax squared plus bx plus c, and you'll notice a in this case is the coefficient in front of the x squared. It's no longer a 1. So let me give you an example of the multiplication that would get something like this. If I multiply the two binomials 2x plus 3 and x plus 2 together, I get this quadratic. Now you'll also notice that while 3 and 2 do multiply to 6, and 2 and 1 do multiply to 2, that's the first and the last terms, all right? The middle term is not going to be the sum or difference of the 3 and the 2, like it was when we had a 1 as a coefficient in front of the x squared term. So what we're going to have to do on any problem like this is identify the factors of the a term, which is a 2 in this case, and the factors of the c term, which is a 6 in this case. And then we can either do a method of guess and check, which I'll do for some instances, or there's another method we'll use that I'll show you as well. So let's take a look. So here's an instance where I have the quadratic with a coefficient other than 1 in front. I take and look at the factors of 3 and 1. Well, there's really only one way to get 3, and that is 3 times 1. And there's a couple ways to get 6, 1 and 6, and 2 and 3. So whenever I have only one factoring to get the a term, I use what's called a guess and check method. Now there's this other one called an X method, which I'll show you after. So my initial idea is to say, okay, well, there's only one way I get 3 by multiplication, and that's 3x into x. Now what I'm going to do is guess and check ways of getting 6 and then adding my middle terms to get 11. So I know that since all these terms are positive, I have to have a plus and a plus. So what I can do is I could guess that if I had a 1 and a 6, I could put a 1 here, which gets me a multiplication of 3 times 1 of 3, and then a 6 here, which is a multiplication of 6 and 1. And then I'd have 3 and 6, which is 9, not 11. I could also put my 6 here, but then I've got an 18 when I multiply the first term times the last term, and then a 1 if I put a 1 right here and do this multiplication. That's not going to do it either. So now I have to guess either 2 and 3. I'm going to put a 3 here and a 2 here and watch what happens. When I multiply the first and the last term together, I get a 9, and the second term and the first term here together, I get a 2, and 9 and 2 is 11. So notice I get 3x squared, I'm foiling, plus 9x plus 2x plus 6. Notice 3x squared plus 11x plus 6 is this term, hence my factoring is as such. Now I also mentioned we could do this factoring another way, and it's by using what I call an X method. Now let's draw an X, and what we're going to look for in this case is two numbers that give you the A times C product, or in this case 18, because that's 3 times 6. That's my A term and my C term. And then we're going to look for two numbers that get you plus or minus the B term, and in conjunction get you that multiplication of 18. And that B term in this case is 11. Now I know all these numbers need to be positive in order to do this. So if I say, all right, I want two numbers that multiply to 18 and get me 11, that's going to be 9 and 2. Now, here's the trick of this. These are actually going to be the inside values of my factoring, all right, or my foiling, if you will. So here's what I'm going to do. I'm going to write down my 3x squared plus 9x plus 2x and then I'm finishing with my c value of 6. Remember, these two values here are getting me my b. So notice, now I have 4 terms, and I can group and factor these. Notice in this first term, I have a 3x in common, which means I have an x plus 3 left. And in these two terms, I have a 2 in common, which gives me an x plus 3 left. Now, we've done this before. X plus 3 is in common, and what's left is a 3x plus 2. And you'll notice the factoring is exactly the same as my guess and check. Again, I like using guess and check when there's only one multiplication because I can do that in my head pretty quick. This may work better for you, I'm not sure. So let's go do another problem. Here's a very similar problem. Notice factors of 5 and 1, or 5 are 5 and 1. And 14, I've got 1 and 14 and 2 and 7. So if I want to guess and check this, which is my preferred method, I would take and list my 5x. My x, I need two numbers that multiply to 14 and add to negative 17, which means if I'm going to get a positive when I multiply and a negative when I add, I'm going to need two negatives. So now I could use 14 and 1, but if I put 14 here, that's going to be a problem because 5 times 14 is a huge number. If I put 1 here, that's 5, but then I have a 14 here, and 5 and 14 is 19, no go. So I'm going to go with a 7 and a 2. Again, if I put my 7 here, I have a 35, which seems a little big. So I'll put my 2 here and my 7 here. Notice that's 5x squared minus 10x minus 7x plus 14, or 5x squared minus 17x plus 14. Thus, that's my factoring. And again, if you want, if you're comfortable with it, we can use our x method and say, well, what's a times c? Again, a here, c here, b here. So a times c is 70 in this case, and that's a positive. And b, we're looking to add or subtract to that. We have a negative 17. 7 and 10 will do it if they're both negative. So again, we list our first term, which is 5x squared. These two terms are going to be my inside terms of my foiling. So again, I have negative 7x minus 10x. And then here's my last term of 14. So in this case, I pull out an x, and I'm left with 5x minus 7. In this term, I pull out a negative 2, and I'm left with 5x minus 7. Notice the 5x minus 7 is a common term. So I have x minus 2 and the common term of 5x minus 7. And you'll notice the two factorings are the same. Again, use whatever way you're comfortable with. Last one, here we go again. I have 2 and 1 as my factors of 2. 12, I have lots of different possibilities here. So it may not be quite as easy to guess and check. But let's go ahead and try. To get my 2, I have 2 and 1. I need a positive and a negative in this case to get to 5. So I'm going to guess and check. If I put a 12 here, I have a 24. That's probably too high. If I put a 6 here, that's not good. If I put a 2 here, I've got a 4, but then I have a 6 inside. That's not good. I need a positive and a negative. I'm going to go with 4 here, 3 here. If I have a positive on the 4, that gets me an 8 on this outside multiplication. On the inside multiplication, I'm going to need a negative 3. And there we have it. So look, 2x squared plus 8x minus 3x minus 12 is 2x squared plus 5x minus 12. So there's my factoring. Again, the more different factors you have, the more guesses you're going to have to make. So in this case, if I use my A and C here, my plus or minus B here, A and C in this case is 24, B is a positive 5, and this is a negative 24. So then I need to find two numbers that multiply to 24 and get me 5. That's going to be 8 and 3. Positive 8, negative 3. Write down first term. The middle terms are my 8 and 3 plus 8x minus 3x. And then I want my minus 12 as my last terms. Common term here is 2x, leaving me with an x plus 4. Pull out a negative 3 here. X plus 4. X plus 4 is a common term. And I'm left with 2x minus 3. Again, same factoring. Now in this case, whenever I have an A term that has more than one set of factors, so in this case, 8 goes to 1 and 8 and 2 and 4. All right, whenever this is the case, I'm going to take and use this X method. I think it's much easier. You can guess check all you want, but I think it's going to take longer. So let's say I need my A and C term here and my B term here. A times C is negative 72. B in this case is negative 6. So I need two things that multiply to negative 72 and get me a negative 6. So here's where multiplying and knowing your multiplication tables is big time. All right, 9 and 8 is the first thing that comes to my head for 72, but that doesn't get me a negative 6. So what other things get me 72? Well, 6 and 12 get me 72. And if the 12 was negative, those would add to negative 6. So there I have it. So I'm going to write down 8x squared plus 6x minus 12x minus 9. Again, I notice I have, a 2x in common here, leaving me with a 4x plus 3. I'll pull out a negative 3 here, leaving me with a 4x plus 3. 4x plus 3 is in common. And I'm left with that 2x minus 3 here. If you FOIL this out, there's my 8x squared plus 6x minus 12x minus 9, which gets me 8x squared minus 6x minus 9, which is exactly what I wanted to get. So my factoring is right here. Again, that X method is used anytime this coefficient in front have more than one set of factors. So in this case, 1 and 15, 3 and 5, I'm going to the X method. AC plus or minus B. 8 and 15, when I multiply those together, that's going to get me 120. And then I need a positive 14 when I add. So again, it's going to be necessary to maybe use a calculator and figure out what multiplies to negative 120, adds to 14. 12 and 10 is the first thing that comes to mind, but that gets me a 22 or a 2. How about 6 and 20? That ought to do it, where the 6 is negative. So now, again, 15x squared minus 6x plus 20x minus 8. I look at the GCF here. 3 goes into both and an x. So I have a 5x minus 2. And in this case, 4 goes into both. 5x minus 2. The 5x minus 2 is in common. And I'm left with the 3x plus 4. If you check that by foiling, you'll get exactly that trinomial. 18 is even worse because I have 1 and 18, 2 and 9, 3 and 6. So definitely going to go with the X method here. and c plus or minus b. It's negative 180 and 41. And again, I'm probably going to have to go to my calculator to try to figure that out. So we can start from the bottom if we want. I'm going to just go through my factors here. I have 1 and 180. Definitely not going to work because that's not going to get me 41. 2 and 90. Not going to get me 41. 3 and 60. Not going to get me 41. 4 and 45. Whoops. 45. Hey, that gets me 41. If my 45 is positive and my 4 is negative. So there's my guy. And again, you could keep going until you get that difference that gets you a positive 41. So I'm going to write down the first term again. Minus 4x plus 45x minus 10. Look for a common term here. That's going to be a 2 and an x, leaving me with 9x minus 2. And then I have a 5 in common here, leaving with a 9x minus 2. So 9x minus 2 is my GCF again, leaving me with the 2x plus 5. And that's my factoring. So here's a solving problem, and as we've talked about before, whenever we have a quadratic, the idea is to set aside equal to 0. So I will bring the 19 over by subtracting and the 7 over by adding. We notice that 10 has multiple factors of 10 and 1 and 5 and 2, so we'll go to the x method. A and c. And I need to multiply to 10. Or sorry, I need to multiply to 70. And plus or minus b needs to get negative 19. Again, I can go through all my possibilities. 1 and 70, no go. 2 and 35, nope. 3 is not going to go in. 4 doesn't go into 70 evenly. 5 goes into 70. How many times does that happen? 70 divided by 5 is 14. And there we have it. So if I put a 5 here and a 14 here, minus minus, and then write 10x squared minus 5x minus 14x plus 7. This should work. So I factor out a 5x, leaving me with a 2x minus 1. Pull out a negative 7. Left with a, let's see, 2x minus 1. GCF is a 2x minus 1, leaving me with the 5x minus 7. Problem factored and solved. Now that's factored, but we have to solve this. So zero product principle says 5x minus 7 equals 0. 2x minus 1 equals 0. Add 1. Add 7. 5x is 7. Divide by 5. X equals 7/5. 2x is 1 divided by 2. X equals 1/2. Similar problem. It's always my intent to try to keep my a term positive. So I'm going to take the 2x over to this side by adding 2x and the 18 over to this side as well by subtracting 18. So if I add 2x squared and subtract 18, I'm going to write this in descending powers of x. Like so, and set that equal to 0. Notice since my a term only has factors of 2 and 1, I'm going to go back to my guess and check. I'm going to put a 2 here and a 1 here because there's only one way to get 2. Now there's several ways to get 18. I can go 1 and 18, 2 and 9, and 3 and 6. I need to get a 9 when I'm adding. I know that if this is a negative 18, I have to have a positive and a negative in here somewhere. So let's see, to get a 9. 12, if I put a 6 here and a 3 here, there's 12 and 3, which gets me a 9 as long as the 6 is a negative and the 3 is a positive. All right. Now again, if you're not comfortable with this, go ahead and use that x method. That'll work for you as well. So in this case, I have 2x plus 3 is 0. Subtract 3, giving me 2x equals 3, divided by 2, and x equals 3 halves. X minus 6 equals 0. Add 6, so x equals 6. And there's my solution. So again, this is kind of difficult, and you have some options. Use whichever one you feel most comfortable with. But as I said before, whenever that a term has more than one set of factors, definitely go with the x method. All right?